So coming to the afterburner of turbojet. So generally for a turbojet, generally in a turbojet com- we have inlet intake or intake, compressor, combustion chamber, turbine, and nozzle. And afterburn, when we add an afterburner is a second combustion chamber which is used in military aircraft with to get higher thrust. So an afterburner is also called as reheat. Second combustion chamber of a turbojet or turbofan engine. Immediately in front of the engine's exhaust nozzle, the injection and combustion of extra fuel in the chamber provides additional thrust for takeoff or supersonic flight. As you can see, this is a turbojet engine with intake and a compressor, a combustion chamber, turbine, and nozzle with an afterburner. In most cases, the afterburner can nearly double the thrust of turbojet engine. Since the jet nozzle must be larger when using the afterburner, an automatic adjustable nozzle is an essential component of afterburner system because the afterburner sharply increases fuel consumption and is generally less effective at subsonic speeds. Its its use is for the most part restricted to supersonic military aircraft. We cannot use afterburner in commercial aircraft as it takes up more fuel because when we have a bigger nozzle, the afterburner has more air intake and then it can produce more thrust. So it is a secondary combustion system at which it also adds up fuel. So from a normal combustion chamber and also from an aircraft and afterburner, we are having a double thrust and also the fuel is also consumed more than required. So we cannot use this afterburner in commercial aircraft. We just use this afterburner in military aircraft so at a supersonic speeds. And coming to the diagram of an description for this, to move an airplane through the air, thrust is generated by some kind of propulsion system. Most modern fighter aircraft employs an afterburner on either a low bypass turbofan or a turbojet. As we can see, the free stream from a intake is taken or inlet with a velocity and a mass flow rate with a compressor, a shaft, a burner, and a turbine from a nozzle to afterburner. The fuel is also taken at a burner and also at a afterburner. In order to in order for fighter planes to fly faster than sound at supersonic speed, they have to they have to overcome a sharp rise and drag near the speed of sound. A simple way to get the necessary thrust is to add an afterburner to a coarse turbojet. In a basic turbojet, some of the energy of the exhaust from the burner is used to turn the turbine. The afterburner is used to put back some energy by injecting fuel directly into the hot exhaust so that we'll get more energy or more power. The nozzle is a basic turbojet. The nozzle of the basic turbojet has been extended and there is now a ring of flame holders colored yellow in the nozzle. When the afterburner is turned on, additional fuel is injected through the hoops and into the hot exhaust stream of a turbojet, which makes the fuel burn and produce additional thrust. But it doesn't burn as efficiently as it does in the combustion section of turbojet, so that we'll have a more wastage of fuel and the fuel consumption will also get increased. You get more thrust, but you burn more fuel. When the afterburner is turned off, the engine performs like a basic turbojet. Afterburners are only used on supersonic aircrafts like fighter planes and Concorde supersonic airlines. The Concorde turns the afterburners off once it gets into cruise. Otherwise, it would run out of fuel before reaching Europe. Afterburners offer a mechanically simple way to augment thrust and are used on both turbojets and turbofans. Coming to the application of turbojet with afterburner, an afterburner is an additional combustion component used on some jet engines, mostly those on military supersonic aircraft. Its purpose is to increase thrust, usually for supersonic flight, takeoff, and combat. The afterburner process injects additional fuel into combustor in the jet pipe behind the turbine, reheating the exhaust gas. Afterburner significantly increases thrust as an alternative to use a bigger engine with its attendant weight penalty, but at cost of increased fuel consumption, decreased fuel efficiency, which limits in to use to shorter periods. We cannot use afterburner for longer periods because it takes up more fuel and will have less fuel efficiency. And the range and endurance of an aircraft will also get decreased so that when we get it, will turn on afterburner at the initial stages of flight. After coming into cruise, we have to turn off the afterburner so that we will be able to save some of fuel at supersonic flight. This aircraft application of reheat contrasts with the meaning or implementation of reheat applicable to gas turbines driving electrical generators and which reduces fuel consumption. Jet engines are referred to as operating wet when afterburning is being used and dry when out. An engine producing maximum thrust, wet is at maximum power, while an engine producing maximum thrust, dry at military power. As you can see, this aircraft application of reheat. In this fighter aircraft, we can see there is a from nozzle we are getting flames. From the here we had an afterburner for more thrust, so that an aircraft, the military aircraft, will move faster than before, faster than the normal speed. The maximum thrust vector is at the maximum power. When we have to say it is in a maximum power, we have to say it is at maximum thrust vector. And when the engine is producing maximum thrust or drive, it is at military power. And coming to a turbojet engine equipped with an afterburner is called an afterburning turbojet, whereas a turbofan engine similarly equipped in sometimes called an augmented turbofan, which is a normal name given to it. A dump and burn is an airshow display feature where fuel is jettisoned. The intentionally ignited using then intentionally ignited using the afterburner. A spectacular flame combined with high speed makes this is a popular display for air shows or as a finale to a fireworks. Fuel dumping is used primarily to reduce the weight of an aircraft to avoid a heavy high speed landing other than for safety or emergency reasons. Fuel dumping doesn't have a practical use. So it's just a normal fire to make popular displays. We use some dump and burn for a commercial aircraft They have to dump the fuel so that to reduce the weight and also to get high speed landing for emergency reasons and also for safety. This is all my explanation about turbojet engine with the afterburner. Thank you.